Here we're going to look at a bunch of different exponential models so that you can see how some of these different exponential formulas can be applied. So here I have that a family releases a couple of pet rabbits into the wild. Upon being released, the rabbits begin to reproduce at an exponential rate as shown in the formula below. After 2 years, how large is the rabbit population, where N stands for the initial population and M stands for the number of months? Okay, so that's really important, is that here we're looking at that N is the initial population and M is the number of months. So there's a few things that we've been given in our problem. First, we have been given that we have years. So M should be in months. So here we need to convert years into months. So we do that by using that 2 years, and we're going to multiply this by 12 months per year, and this is going to give us 24 months. Okay, so we got to run our conversion. Now the second thing we know is we need to know what N. So N is going to stand for my initial population of rabbits, and my initial population of rabbits is 2. Now how do I know that? I know that because a couple of pet rabbits, and so here we would have 2. So in this case, our formula is P equals 2e to the 0.5 times 24. And so we would go ahead and use our calculator to put this in, and when you're done, you're going to come out with 325,510 rabbits. So after 2 years, we have 326,000 rabbits floating around. Okay. Alright, this next one is talking about money. So suppose that $10,000 is invested at an interest rate of 5.4% per year, and we are compounding continuously. So compounding continuously means the PERT formula. So it means we are looking at A equals PE to the RT. Okay. Now with that, we want to find the exponential function that describes the amount in the account after T years. So what do we know? We know that P is going to be my $10,000 that I invest. My R is going to be 0.054. It's your rate, but changed to a decimal. And then we are compounding continuously. So my equation or formula is going to be A equals 10,000 e to the 0.054 t. Okay, and that's all we're asked to do for that first part. The second part wants to know your balance after 5 years. So here we have to use the equation A equals the 10,000 I put in, e to the 0.054, but we have 5 years, so we have to multiply by 5. Again, we're going to input this into, say, your calculator, and when you're done, you are going to come out with $13,099.64. Now the biggest thing to make or to remember about money problems is you always want to round to the nearest cent. Alright, here we have that a lake is stocked with 640 fish of a new variety. The size of the lake, the availability of food, and the number of other fish restrict the growth of that type. And it's limited to 3,040. The population of fish in the lake after time t in months is given by the following function. find the population after 10 months. So here what's really important to note is that t is given in months. And so here what we're looking for is we are looking for p of t, which is going to be 10. So this is going to be 3040 over 1 plus 3.75 e to the negative 0.32 times 10. So one of the things that you're going to notice about a lot of these exponential models is that it's just simply a matter of identifying the variable that you need to plug into and then simply using your calculator to find your result. So here you're going to come up with 2920.98. So the fish population after 10 months would be roughly 2,920 fish. And that's mostly because you can't have part of a fish. Okay. Alright, here we have that the half-life of radium is approximately 1,600 years. Determine A. So this is what we're trying to find. We want to find the A value here. So that A of t equals A naught A to the t describes the amount of radium left after t years, where A naught is the amount at time 0. Okay? So there's a few things that we need to pay attention to. First, we need to look at the formulas to use. So we have a half-life. So a half-life would say A of t divided by 2 is equal to A naught A to the t. Okay. So we know that we have, say, the half-life. Well, the other thing we know about this is that half-life is very similar to your decay, which is where this formula comes into play. So we have a half-life of 1,600 years. Okay, so what that means is that I have A of t equals A naught A to the t. So if I want 1,600 years, I have my A of 1,600 years is equal to A naught A to the 1,600. Okay? Now I have to use that idea in order to solve. So in this case, what do I know? If I know that my A naught is the amount of time, or is the amount of radium at time 0, then I know my half-life is going to be half of that. Okay, and so if my half-life is approximately 1,600 years, then what I know is that not only does A of t equal my initial equation, but we can say it holds true that this is also the value when my A naught is at half. So we can use that idea to solve. So here what's going to happen is my A naughts go away, and what I'm left with is that my A to the 1,600 is equal to 1/2. I need to solve, so in order to do that, says that I need to do the reverse. Okay, this number right here is a power, so I need to change it into a root. Okay, and so what happens is essentially I am going to take the 1,600th root of A to the 1,600 is the 1,600th root of 1/2. Okay. Now, nobody likes to look at it that way, so instead we like to use our exponential powers. And so what we know, okay, or what we have to remember, is that a power is a whole number. The root is a fraction. Okay, so in this case we would have that my A is equal to the 1/2 raised to the 1 over 1,600. And the reason for that is because we know that the denominator here represents your root. And so in this case, We want to go out to 6 decimal places, so we get 0.999567. Now once we find that, we want to go ahead and use it. So here we want to know how much of a 1 gram sample would remain after 100 years. So here we know that T is going to be 100, and we also know that your A naught value is going to be 1 gram. And so here with that we can plug it in. So we would have A of 100 is equal to my 1 gram times my A value, 0.999567, and we're going to raise it to the 100. So in this case, what we have left is 0.958 grams. Now we can do that exact same thing with the third one. We want to know how much is left after 1,000 years. So in this case, again, my T is 1,000, and my A naught is still going to be 1 gram. So here we would still have my A of 1,000 is equal to 1 times 0.999567, this time raised to the 1,000. So here we would end up with 0.648 grams. All right. So let's say you have $3,500 that you want to invest into a savings account for 2.5 years. So first and foremost, we know that T is going to be 2.5. Essentially, you find 2 accounts. So we have Bank 1, and in this case, my Bank 1 is offering a rate at 0.0275. and it is compounded monthly, which means 12. We also have a second bank, so Bank 2 is offering a rate of 0.027, and I'm compounding daily, which is 365. In this case, we want to know which bank to choose. Okay? Well, we also know that you have $3,500 to work with. So we are using the compound interest formula. So the formula that we're going to use is A equals P times 1 plus R over N raised to the NT. So here for Bank 1, we would have that my A1 is equal to 3,500 times 1 plus my R is 0.0275 all over 12 raised to the 12 times 2.5. So once you solve, you end up with Bank 1 being $3,748.79. We then have bank number 2. Again, I still have 3,500, but this is going to be different. It's 1 plus 0.027 divided by 365 raised to the 365 times 2.5. So here my second bank would give me a total of $3,744.40. So in this case, you would want to choose the Bank 1 at 2.75% compounding monthly. Alright, so this last one I want to look at is a depreciation. So depreciation is the decrease of an item's value, which can be determined from the following formula. Okay, so it's the depreciation formula, where V is the new value. So if the particular car that you buy upon graduation from college costs $17,500, and it depreciates at a rate of 16% per year, what is the value of the car in 5 years when you pay it off? So here we know that P is going to be 17,500. We know that R is going to be 0.16, and we know that my T is going to be 5 years. So here V is equal to 17,500 times 1 minus 0.16 raised to the 5. So here you end up with that car is only worth $7,318.71. So there you have 6 different examples, all dealing with exponential models in different forms. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed these story problems, and I'll see you next time.